me the derivative is 2x. What do you know about 2x?
X squared.
Good.
Just
Okay.
stick up in the top.
So you get x squared. So the original function is x squared. Oops, I better write it even with the 2x. So 2x goes with x squared. What about x?
1 over x. 1 over x.
Ooh, 1/2 x squared. Yeah, that's a good call. Now, for those of you that aren't quite seeing it, that's okay. What about just x squared? What would that go with?
Oh, 1 over x, -2. 1/3 x cubed.
So you're figuring out something, aren't you?
Oh, Caleb,
Or
aren't
you
you still
looked
a
ahead.
smart ass? I'll do this next one.
Okay. All right, let's go ahead and skip to cosine x here. What would the cosine be?
Negative sine.
You think?
No.
So the derivative of sine, negative sine is cosine?
You bet. Oh, no.
What about that?
There you go. Oh, yeah, that's right.
Okay, so now what we're going to do is we're going to talk about antiderivatives. So instead of taking a function and finding its derivative, we're actually going to go backwards. Okay, we're going to undo that differentiation process. And so we've got some things we need to talk about. And the first is what a definition of an antiderivative is. Anti kind of means opposite. All right, so a function f is an antiderivative of f on an interval I if f prime x equals f of x for all x in I. So basically, we kind of found the antiderivatives. And so how we represent antiderivatives is from theorem 4.1. It says if f is an antiderivative of f on an interval I, then g is an antiderivative of f on the interval I if and only if g is of the form g of x equals f of x plus c for all x in I where c is a constant. So now you're utterly confused. Okay? Okay, so anyway, basically this is what it's saying. The operation of finding all solutions of this equation is called antidifferentiation. We won't refer to this as antidifferentiation. We're actually going to refer to this as integration. Okay, indefinite integration. And how we find the integral is we use the integral sign. So that little squiggle. Okay, so remember to find the derivative, we use the prime. Y prime, f prime. To find the integral, we use that little squiggle. And so first of all, we got to talk a little bit about what that means. We have the integrand here. The integrand is the function you are trying to integrate or find the antiderivative of. Okay? We have our variable of integration, dx. Generally, it's always going to be dx unless, say for example, the function was in terms of n. Like if it was 5n, then this would have to be dn. Okay, so the variable of integration has to match the variable that you're finding the antiderivative of. Okay, so then we have our little integral symbol. And so what I get with my answers, I get big F of x plus c. C is our constant of integration. Now you're probably wondering, why do you need a c? Well, let's think about things real quick. I'm going to give you three functions. Okay? I want you to tell me what the derivative of each of these three is. So that's the derivative, right? So basically with integration, we are starting here with the 2x and we're going backwards. So if you notice, each of these three functions gives us a derivative of 2x. Okay, so what this plus c accounts for, this plus c accounts for all of the possibilities you could have right there. Okay. Yeah, and so what we're going to do now is we're going to go ahead and talk about the power rule. The power rule is essentially what I think this one was doing when he was finding the antiderivatives of. Okay? Basically what it's saying, if you want to find the antiderivative of, or if you want to integrate x to any power, you're going to take x to the n plus 1 and divide it by that n plus 1, and then you're going to add c. Now notice, we have kind of a requirement here, because if n is -1, what happens? You divide by 0, okay? You can't divide by 0. And so we have a special thing for n when n equals -1, and it deals with logarithms. And we will take care of that in chapter 5. So let's go ahead and describe the antiderivatives of 3x. So basically what that means is we're integrating 3x dx. Yes, you need the dx. That is your variable of integration. So using that power rule, what are you going to get? 3 plus c. What do you get?
Well, what's x and n small r?
Yeah, this is the power. I just want to see if somebody can get it. 3?
3x squared.
Yep.
Over 2.
And then plus c.
Plus c.
Now, this is the answer. Now, for those of you that are wondering where that came from, first of all, the 3 is a constant. It just stays put. Then what I do with the x is this is actually x to the first power, right? So according to the power rule, I'm going to add 1. So I get 1 plus 1, which is 2. And then I'm going to divide by that same number 2 in the denominator. And that's just the power rule. This is actually undoing differentiation. So if I were to take the derivative of 3x squared over 2, I'm going to get 3x.
This makes me so mad. We could have used this for that graph problem.
Now what?
Bottom just ones.
Yeah. Yep. Okay, so let's go ahead and look at this one. Okay. Now, what we're going to do is we're going to just break these and look at them individually and find the integral of each of these. So first of all, x cubed. The integral of x cubed will be, what do you do? Instead of subtracting 1 like we did with derivatives, you're adding 1. X to the 4th over 4. Or another way you could write that if you wanted is you could write it as 1/4 x to the 4th. Same thing. Plus, what's this one going to be? Yep.
The bottom is just always the same number.
Yes.
Wow, that would be much easier.
And then plus
4x to 2.
4x. And then plus c. Now, whenever you have a constant, in this case the number 4, and you find the integral of it, you basically just add the variable in. Because really, what this is x to the 0 power. Okay, because anything to the 0 power is 1. So you add 1, you get x to the first divided by 1. Okay. Alrighty, let's look at this one. Now this one's a little different because it's in the denominator. So no, you don't just add it in the denominator. We have to rewrite this. And how can we rewrite it? X to the -3rd. So I'm finding the integral of x to the -3rd dx.
No, x to -2.
Yep, x to the -2. X to the -2nd over -2nd, and we're going to add c, but you know I'm not going to let that fly because of the negative power. So first of all, I've got a negative sign from the -2. Fraction. If I want to move that x to the -2 and make it positive, I got to move it down. Yep, 1 over 2x squared plus c. No, it's plus c. It's always a plus c. Okay, let's look at this one. So this one's going to be x to the 1/2. So now, sometimes with fractions, these can be a little difficult. So we're going to talk about some things that help. Okay, this is what I do. If I see I've got x to the 1/2, in order to add 1, you're basically adding 2 over 2. So the easy way is to just say 1/2 plus whatever the denominator is. Okay, so 1/2 plus 2 over 2 is going to be 3/2. Okay, now when you divide by 3/2, that's the same as multiplying by the reciprocal. So it's the same as just multiplying by 2/3. So that's the easy way. Flip that fraction and just multiply it by that.
C.
And then plus c. So example, if you have like x to the 4/5 that you got, you would take that times 5/4. Okay, so it's one of those, you just flip the exponent and you should be fine. Okay, what do you think you're going to do here?
First change it to x to and then bring it up to
I'm going to do something a little bit different. First of all, you are right. We're going to change it as x to the 1/2. There is no product rule or quotient rule with integration.
Well, why is there a plus 1
Okay.
Okay.
Now, what I basically did, if you haven't figured out or seen, this is what I did. And this is what some of my students in the past have called the bunny ears, because you've divided each of the terms by the denominator and you've split the fraction up. And so we still can't find the integral yet. We still have to do some simplifying. First of all, x to the first over x to the 1/2 yields me with x to what power? X to the 1/2, because you subtract exponents. Remember, we take 1 minus 1/2. And then this one here, I'm going to move that up by writing that as a negative 1/2. Now, all we have done is simplify. We have not done anything else. Okay, we haven't found the integral or any of that yet, and that's what we need to do in the next step. So I need to integrate x to the 1/2, so I need to add 1 to that exponent. So if you add 1 to that exponent, you get x to what power? The 3/2, which means you multiply by 2/3. Okay, now I'm going to add 1 to the negative 1/2. Yep. If you take negative 1/2 and add 1, you should get 1/2. So you multiply by 2 over 1, which is the same as multiplying by 2. Okay, questions? All right, last one we're going to look at, I think, today, and that's the sine and cosine functions. And so first of all, the integral of cosine is positive sine, and the integral of sine is negative cosine. So this is actually the opposite, because if you remember, the derivative of sine was positive cosine. Derivative of cosine was negative sine, so they flipped. So just for kicks, what do you think the integral of 4 sine x will be? Okay, all it's going to be, the integral of sine here is negative cosine. So all it's going to be is negative 4 cosine x plus c. That's it. There's nothing else there that you need to do. Let's look at another one. Sine over cosine squared. Okay, there is no product rule, there is no quotient rule. It's not just the derivative of sine over the derivative of cosine squared. So what we need to do is somehow manipulate this. So I gave you some sheets of paper. You need to find the trigonometry one, and you need to find the derivatives and integral one. Okay? So the trigonometry one and the derivatives and integrals sheet. Now, first of all, if you look at the derivatives and integrals sheet, you're going to notice when it says basic integration formulas at the very bottom. Okay? Basic integration formulas here at the very bottom. You don't just have a sine and a cosine function. You also have a, we're looking at specifically like number 8 now and on, tangent, cotangent, secant, cosecant, secant squared, cosecant squared, secant tangent, and cosecant cotangent. So see, we have a lot more trig functions there. And so what I'm going to do here is I'm going to try and rewrite this. Okay? I know that cosine squared means cosine times cosine. Right? That's what cosine squared means. I also know
Sine, cosine, tangent.
that sine over cosine is tangent. Good. So if I do sine over cosine, I still have a cosine in the denominator. And so as you've already said, sine over cosine is tangent. And what is 1 over cosine? Now if you forget, that's why I've got that trigonometry sheet. And that trigonometry sheet shows you that 1 over cosine is secant. So now in looking at this, I have tangent times secant, which is the same as secant times tangent, which is located on your integral sheet at number 14. The integral of secant tangent, according to number 14, is secant x plus c. And there you go. So you might have to manipulate those trig functions around, and you have that trig sheet which should help you remember what those are. All right, so we are going to go ahead and continue with the last two, which deal with general and particular solutions. And we're going to deal with those tomorrow. But for today, you can go ahead and get started. Pages 255, 256, 5 through 41, the odds.